All right. So this is going to start the videos for module 5, which is some more organic chemistry. We're just continuing the other functional groups. So last week I had it kind of grouped based off of an introduction, naming, and then reactions. But this week it makes sense to just keep the chapters as they are. So the first video will be over chapter 14, second, chapter 15, and so on. So just a review of our functional groups, I really hope and I really strongly suggest that we have these committed to memory. So this week, we will be talking about the benzene ring a little bit. We'll talk about amines, aldehydes, ketones, carboxylic acids, and amides. I'm cutting out ester and ether. There's just so much, so we don't need to worry about those. So aldehydes and ketones. So what the heck do they look like? So they both are composed of a carbonyl group, and a carbonyl group is a C double bonded to an O. So carbon double bonded to an oxygen. The only difference is an aldehyde contains this C double bonded to an O on a terminal carbon. So C double bond O group is on a terminal carbon, meaning it's the last in the chain. And a ketone has this C double bonded to an O on a middle carbon. All right. So the way I always remember this is that an aldehyde is a terminal carbon, and because A starts the alphabet, an aldehyde is on a carbon that starts the chain. It's kind of it's not, I don't know, it's not a great analogy, but. So just a little bit of properties. So aldehydes and ketones, we can generalize their properties all as one. So they are soluble in water, but they can't hydrogen bond, which I know we haven't talked about what hydrogen bonds are, but they can't hydrogen bond, and so they have a lower boiling point and melting point than alcohols, but they still have higher than alkenes and alkanes and alkynes. So how the heck do we name aldehydes? So this screen we've seen a lot, right? So the same general naming rules apply, only we have a new suffix, right? And the suffix corresponds to our functional group. Right? And so this time, if we're naming something with a aldehyde on it, the suffix is going to be anal, basically. So that's well, that's that. Everything else still applies. So we still want to figure out how many carbons are in the chain, and that will be the parent name. We still want to any branches and stuff, take care of that with a prefix. Everything else still applies. So let's go ahead and name this structure I have here. So first, we're going to count the carbons. So I could count them right to left to right, and it's up to me to determine which is correct. So like I said, when we have functional groups present that's not alkanes, it's all about making the functional group the star of the show. So right here we have our our aldehyde functional group. So I'm going to want to use the second numbering here. I'm going to want to number from right to left because I want to make that aldehyde the star of the show. If I can put them at the lowest possible carbon, I am. And with aldehydes, they're always going to end up at 1 because if an aldehyde is on a terminal carbon and I'm trying to make the aldehyde the star of the show, I'm always going to put the aldehyde at 1. So this is a 4-carbon chain because an aldehyde is present, it's going to have the ending anal. And then because it's 4, it's going to have the prefix but or but. So yes, this one is butanal, but it's pronounced butanal. Butanal. It's quite the example, right? I didn't even realize that example was butanal until I was actually presenting it. And that last time I presented this slide was when I was being observed. And I got to it and I went, oh, yep, this says butanal. Okay. But anyways, okay. Back to naming. Okay, so with this functional group, we don't have to tell the audience what number carbon the aldehyde group is coming off of. And again, that's because if an aldehyde is present, it's always going to land on carbon 1 because an aldehyde is terminal and I'm going to want to make it the star of the show. So I'm going to want to put it at 1. So aldehydes, we don't have to tell the audience what number. All right. So the next slide is going to look like your question 1. So it's asking us to name the following compound. So I can number left to right or right to left. And like I just tried to drill home to you, I always want to make the aldehyde the star of the show. So I'm going to number from right to left. This is a 6-carbon structure. So I'm going to use hex. And because it's a aldehyde, hexanal. And I don't have to, there's no branches, so I don't have any other words going on there. And there's no, I don't have to tell my audience what carbon it's coming off of, because if it's aldehyde, it's always coming off of carbon 1. Okay. So ketones, right? Now this is the same looking functional group, but now the C double bonded to an O is in the middle. All right, all the same naming rules apply. But now if it's a ketone, our suffix is anone. Okay, so instead of anal, it's anone. Right. So we're going to number our carbons. 1, 2, 3, 4, 5. I could number left to right, right to left, but I want to put the ketone at the lowest possible carbon. So going from left to right puts that functional group at carbon 2, which is the lowest it would be, because if I were to number the opposite direction, it would be at carbon 4. So this is the desired going from left to right. So I know I'm going to use the suffix anone because there's a ketone present. It's a 5-carbon parent chain, so I'm going to use the prefix or the parent name pentanone. I didn't mean to put a space there, but writing backwards. So here I do have to tell my audience what carbon this group is coming off of. I didn't mean to click this. Okay. So this is coming off of carbon 2, right? So with ketones, they're going to be the opposite. I shouldn't use the word opposite. So ketones, you will absolutely have to specify what carbon, right? Because they're going to be a sandwiched carbon. We can't always, we know for sure they can't end up on number 1. All right. All right, so we're almost done naming this. This guy happens to have a branch, so we need to take care of that. So that branch is coming off of carbon 3, and it's a 1-carbon branch, so it's a methyl group. So 3-methyl-2-pentanone. All right. So let's do an example from your OWL. All right, so I could number left to right, or right to left. I always want to make the functional group the star of the show, and so I'm going to choose this naming convention. So anone, because we're dealing with a ketone. Hex, because the parent chain has 6 carbons. And I need to tell the audience what carbons that functional group's coming off of, carbon 2. Now, there's no other branches or anything on this example, so we don't have to worry about that. The full name is 2-hexanone. All right. So one other thing to mention about ketones and aldehydes. So there's this reagent called Tollens reagent. I meant to erase this from the slide. I forgot to. Okay. So there's this reagent called Tollens reagent, and it tests for the presence of aldehydes, and it does not react with ketones. So this reagent allows us to distinguish between an aldehyde and a ketone. All right. So if an aldehyde is present, this reagent will react and create silver. But if if a ketone is present, then it won't react. And so here in this test tube, it turns silver, so there must be an aldehyde present. In this test tube, it's a ketone because it didn't turn silver. All right. And I believe that's the end. Yep. All right.